We're very much in the middle of a golden age of discovery in astronomy, thanks to satellites in orbit around the Earth and big telescopes on mountaintops on our surface. This is what's called the Very Large Telescope. There's a scale model of it, a quarter size at the back of this room, a quarter size, and that's pretty big. But there are still many mysteries that we still have to answer. Even in our own Milky Way, not only do we not really know what it would look like from the outside, but in terms of how far away certain stars are and how they're moving around the Milky Way, we can count only a few 100,000. Now, this new satellite that's recently been launched by ESA, the European Space Agency, is called Gaia, and it's currently just started a survey to look at 1 billion stars, to look at how far away they are and how they are moving around in our Milky Way. And to do that very accurately is having to move very far away from the heat of our Earth, 1 million kilometers away. In contrast, the Hubble telescope is in low Earth orbit. But thanks to that and the regular upgrades to its instrumentation by astronauts, it allows us to take the deepest ever image, this shown here, of a very tiny bit of sky which reveals a myriad of galaxies, some nearby but some incredibly far away. So most of the normal matter in our universe is not normal, it's this dark material. And this is my colleague of mine down a mine in North Yorkshire, looking for the particle that's responsible for this dark matter. And this is a simulation which kind of tries to synthesize how our universe has changed. So the blue and the green relate to this material called dark matter, and it's this which is formed along filaments for which normal gas falls towards it, and that's the thing that produces galaxies. So if there wasn't this glue of dark matter, then our universe will be very different and may not even be the galaxies that we do see. So in the exhibit adjacent to this auditorium, we have a scale model of one of these antennae which are in a very high plateau in northern Chile called ALMA. And these arrays, these radio telescopes, are looking at the incredibly cold universe. In the next decade, in southern Africa, in Australia, we'll be building the Square Kilometre Array, a giant radio array to look for the distribution of hydrogen in the entire universe, to try and study something called a force called dark energy. So Hubble has been in orbit for about 25 years. So in 4 years' time, its replacement, which is called the James Webb Space Telescope, will be launched. It's much bigger than Hubble, and so because the telescope doesn't fit easily into a normal rocket, it's going to have to go up into space, and then the solar shields will deploy. The telescope mirrors themselves will also deploy. And what James Webb is going to do is going to allow us, through infrared light, to look at the first ever galaxies in our universe. And it's also going to allow us to study planets around other stars. When I was at school, there were 9 planets in our solar system. Now there are 8. Pluto got demoted. But altogether, there are thousands of planets around other stars which we found. In a few cases, if you blot out the star, you can see the points of light, 3 points of light here. These are planets orbiting a very nearby star. In some cases, we can see the shift as the star or the planet move around their common center of mass. And in a few cases, like this is a technique called a transit technique, where a planet passes in front of a star, causes a tiny dip in its light. And in that way, a telescope also in orbit called Kepler has been able to find thousands of planets in other solar systems. Here at the top is a new solar system found by Kepler, and at the bottom are the inner rocky planets in our own solar system. So Kepler's found things even smaller than our own Earth. And in a few other cases, it's found planets orbiting not one star, but two. But these planets are incredibly faint, incredibly far away. And so the biggest telescopes we have right now, even the James Webb, isn't going to allow us to really study these things, to look for signatures potentially of life on those planets. So we have to build even bigger telescopes here on Earth. And the Europeans, including the UK, are building what's going to be called the extremely large telescope. How big? The mirror is as big as this auditorium. And the whole building is about as big as Wembley Stadium. And it's going to allow us, amongst other things, to study these newfound planets around other solar systems in our own Milky Way. And let me leave you with one final thought. How big is the universe? Well, in case you can't read the words in the sand, there are far more stars in our universe than there are grains of sand on all the beaches in all the world. Thank you.